So my talk is actually on why do we even decentralize trustless systems? Why is decentralization actually important? Now, a really common wrong answer is actually that decentralization democratizes control over the system. We see these centralized systems, the traditional systems, and we think, oh, we don't want so much power in this unaccountable central entity. We want the users, the people, to control the system. Now, this is a very common thing you'll hear about proponents of the decentralized systems. But then, actually, I don't think this is the central point, because if you think about it, if the question is really control, it's voice, it's participation, then how about we elect Congress, right? Everyone in the US elects Congress. Congress passes a law commissioning a government-owned blockchain. Now, is that more decentralized than any blockchain ever because it involves the largest amounts of people in this decision-making process? Obviously not. So what do we really mean by decentralization is actually decentralization helps us regularize incentives. What this means is that if we have one participant or just a few participants, it's fundamentally impossible to actually model what they're going to do. They might have, their dream in life might be just to destroy Bitcoin. You don't know. But if we have enough people, we can actually reason about their rational incentives, what they're going to do, and build a cryptoeconomic mechanism to constrain that. So what this means, the takeaway is really that I think that some amount of decentralization is definitely necessary for trustless like cryptoeconomic systems, but it's not sufficient. And instead of trying to maximize the number of participants and make everything more democratic, the much more important thing to do is actually to carefully design the system so that no matter how many people participate, as long as it's not ridiculously small, then they have the right incentives and the protocol is gonna be stable and produce the results we want.
All right, thank you very much. The next person is Aditya Shanker. Do we have that person? Hello. Do you have slides?
We can present it just to give our audience some context on what I'm going to talk about. Okay. Hi, everyone. So my name's Aditya Shanker, actually. There's an H after the S. So firstly, I work in capital markets. I'm from Toronto. Small disclosure, all opinions expressed here are purely mine, not in any way expresses the views of my organization where I work or any other affiliates I'm with. So I'm going to give this talk. It's a little bit of a long heading. The point of my talk is going to be why Libra provides inspiration for what a real, true global currency should look like from an academic perspective. So firstly, stablecoins. The problem statement stablecoins have been trying to solve, there's essentially two problem statements. One is provide a hedge against volatility of crypto assets. The second problem statement is actually provide something that you can buy your coffee with. So we'll focus more on the second problem statement. Lots of stablecoin ideas have been proposed over the last couple of years. And then came Libra, and I thought the most interesting idea in Libra was the Libra Reserve. So why is that an interesting idea? Because it's actually backed by a basket of so it's a diversified basket of government bonds. So that immediately gives Libra true value, which mostly everyone's been asking for. Is that you can't really have value for a currency unless you're backed by something that's real and tangible. Secondly, it's one of the first ideas to be proposed in the world where the value of the currency, the risk is diversified. So usually when you're holding onto your local currencies, a euro or a dollar or an Indian rupee or whatever, you're exposed to localized risk within your country. If your central bank messes up, you're holding on to nothing. It's total garbage. So why Libra now provides an interesting solution to the whole world and every single country is that you're holding onto something that even if your central bank messes up or any other central bank in the world messes up or some global catastrophe happens, the Libra Association will rebalance it. They will rebalance the currency with other underlying assets that will preserve its value. So I think that's a really interesting experiment to look forward to. Lastly, negative interest rates. If you look at, done? Sorry. That was a lot. So all right, thank you.
Okay, so now we have Michal Monit. Are they here? Oh, hey.
Hi everyone, my name is Michael and I will tell you a bit more about exponential organizations. So you might think exponential is a curve. Yes, growth is really important, but I'm talking about the type of organizations that can have disproportionately large impact. And the reason why those organizations can have really large impact is because they tend to apply some of the EXO attributes, and there are 10 of them. So if they apply 5 or 6, they have a really good chance. But then they have to have MTP, which is the massive transformative purpose, on top of that, which is kind of one guiding rule on top of them. Now, at this point, we have around 2,000 community members in 70 different countries, and one of the things that is bringing all of them together is this MTP of transforming the world for a better future. And if this sounds ridiculous for you, that's great, because it means it's massive enough, transformative enough, and it might be worth actually going after. How can we get there? Because that's the key question. So how can we transform the world for a better future? So you already know about the XOL methodologies, so we can apply some dog fooding. We can start with the community and crowd, provide them with interfaces to interact with each other and also outside ecosystems. We empower them with algorithms and autonomy. And on top of that, we make sure that the information flows between the different social constructs. And we provide incentives and engagements to reach our goal. And if you look at this kind of description, it looks very, very similar to what most of blockchain or crypto communities are about. So at this point in time, we're in a place where we have the transformative technology called the blockchain. We have this kind of new ethos that allows for us to build this new economic rails and technology layer to transform and catapult organizations, institutions, and communities into effectively emerging economies. And those are economies not because they are limited by certain geography or ethnicity, it's just they are driven by purpose. So they can be fully decentralized. And one of the projects we've been working on is actually live community that has live blockchain. And their purpose, and I'm part of that, is to create positive transformation for the world and also try to make sure that all of the stakeholders also get a piece of the upside. So yes, we're just starting. The network has been live for a year and a half, but it's a very, very long-term and difficult project. So finding repeatable, scalable, sustainable, adaptable models is really hard. So yeah, please grab me in the afternoon or just drop me a line. Thank you.
All right, so now I think we're going with Michael Coblenz. Are they here?
Okay, can everybody hear me? Great. All right, so I want to show you a sample in a new programming language that I'm working on. So we've discussed how smart contracts have been plagued by bugs, and we of course don't like software with bugs. So the question is, how do we get rid of some of these bugs? And so I want to show you a sample of code in a new programming language I'm working on called Obsidian. And the idea is to rule out certain classes of bugs by adopting clever techniques in the type system, so we can rule out bugs at compile time. So the idea is it's not good enough to wait until runtime to do testing because the smart contract might already be deployed. We actually want to defend against bugs earlier compile time. So here we have a tiny vending machine, and the tiny vending machine sells candy bars. And because this one is so tiny, it only stocks one candy bar at a time. So it's always either full or empty. So one observation we've made is that a lot of smart contracts typically have high-level state, and the operations that you can do depend on the state. So for example, the vending machine is either always full or empty. And if it's full, it has some inventory. And in particular, it owns the inventory. So it's not just any old candy that it owns, it's not just a reference to any old candy, but it's a reference to candy that's owned by the vending machine. So when we create a new vending machine, we start out in the empty state. And then when somebody restocks the vending machine, they actually can only restock a vending machine that's empty. So we check statically to make sure that we know that the vending machine is empty. And then to restock the vending machine, you actually have to put in candy that the caller owns. And then the compiler checks to make sure that the body of restock actually does something with its own candy, right? Because if you take an owning reference to a resource or an asset, and you just drop it on the floor, that represents a bug, right? We don't like losing access to cryptocurrencies, or in this case, candy. So we save the candy in the inventory, and we transition to the full state, fulfilling our contract, which says that afterward we're going to be in full state. Likewise, when you buy a candy bar, in order to buy a candy bar, you actually have to deposit a coin, and the caller of buy has to deposit a coin that the caller owns, right? I can't buy a candy bar with your money. I can only buy a candy bar with my money. So from the caller's perspective, when they buy the candy, they must insert a coin that they own, and then afterward, the caller does not own the candy or the coin anymore, because, well, ownership of the coin has been transitioned to the vending machine. So by using a mechanism like this, we can detect bugs in which we incorrectly invoke transactions in an inappropriate state, in which we accidentally lose resources that we should not be losing. Good? Out of time? Okay, thanks.
All right, so now we have Sabine Bertram. Yeah.
I don't have slides, it's just my notes. Thanks. Okay. Yesterday, Hannah Halabode said something that really stuck with me. She said, whenever there's value, there's a double spending problem. And while we can all argue whether data is the new oil, we can probably all agree on the fact that data at least has some kind of value. And double spending in the sense of data means copying that data. And because we cannot really solve that problem, we have those siren servers like Google and Facebook and all of them out there that collect the data and just keep the value for themselves. And this has major impacts on society. I mean, first of all, these siren servers are the only ones that profit from the data, and they increase the wealth inequality gap. And second, the individual's privacy is lost, and the data may even be used against them. So think Cambridge Analytica. So what if we can solve this data double spending problem? I'm a PhD student at the University of Cape Town, and I work on a trustless system for data ownership. My protocol allows for data owners to jointly license their data to third parties that then can run agreed upon, ex ante agreed upon analysis on that data. The individual's true data is augmented with decoy data and then collected in a joint database that I reduce with a mechanism that I call multi-party coordination. Computing hosts then run the analysis if they find that the data license and the code license has been purchased by the third party, and the results are reported back to the third party, who then has to identify which of the results stems from the computation of the true data. The system solves the double spending problem by allowing for pay-per-use licenses for data and code. So it ensures privacy, and it gives the value that is generated by that data back to the rightful owners, the data owners themselves. So if you find that interesting, please find me later. Thank you very much.
Do we skip number 4 or am I wrong? Okay. Hi everybody, my name is William Robinson. I'm someone who tends to work in the shadows. I am an auditor's expert. If you're a fund in Cayman Islands or a foundation in Zug, I may have seen your balance sheets. My goal in life is to give auditors confidence that your assets are real. You probably don't know that I exist or that anyone like me exists, but essentially governments, auditors, they're not technologists. They don't know what digital funds look like or how to think about them. So think of it like a gold mine. If you're an auditor and your client says, I've got 40 million gold in my gold mine, the auditor doesn't go to the gold mine and like lick a rock and say, yeah, I believe you. They hire an expert, they come in, they do this work. And I want to just tell you that if you want to make your auditor's bill cheaper, like you can't really ask an auditor because then they're an advice giver and they can't audit you anymore, so they never want to give you advice because they have to keep that role separate, otherwise they're no longer independent. So I have advice for you. If you ever want to come talk to me, I could tell you how to make your funds cheaper, but your audits cheaper. But generally, the idea is we need to say three things. Existence, can we prove that your assets are there? Ownership, can we prove that you are the person who holds the private key and no one else does? And that your really complicated smart contract that has super crazy governance on who can spend and when works. That's really hard and super expensive. Don't do that. And finally, completeness, like are you hiding funds anywhere? And how do we find those? And generally, the answer is we can't like fight you on that, so we have to just believe you, and it's really hard. And it's a big limitation on our reports. Open problem. You probably could use it with like data tracing if you really wanted to. And finally, valuation. Like if your token costs something that you hold, like where am I going to get that price? Because please don't have it on just one exchange hiding somewhere with like a valuation of $500,000 and $23 of trading volume a day, because I'm not going to be able to audit that. So yeah, that's my like story. I'd love to talk more. It's weird. I studied video game design before doing this, so I don't know why I'm here, but hey.
All right, so now we have Calvin Lee. Are they here? You pass? Okay. James Chiang.
Okay, hi. My name is James. I'm going to talk about generalized contract verification with Bitcoin miniscript in 2 minutes. So the idea is today, if we have like off-chain protocols like Lightning, every Lightning implementation has its own wallet, right? So you basically move your funds from wallet to wallet unnecessarily on-chain, and that's inefficient. And what I want to propose is that we move towards a future where we have wallets which can generally sign for different off-chain protocols, but with certain security or verification guarantees. And I want to explain how that works, or how that could work. So you imagine a wallet that knows nothing about payment channels, let's say a Bitcoin wallet, and it receives transactions representing a payment channel. And the first thing that it does is it knows nothing about the payment channel, but it can construct or reconstruct a state model of the set of all these transactions. It furthermore can determine what the exit states are of this contract. And for example, we can reach P3, we can reach P4 by broadcasting these transactions and having them confirmed on chain. The wallet knows that P4 is a safe state, so that's a state that it would be happy to reach. But there's one more thing that the wallet needs to understand. All the transitions obviously need satisfaction elements, so like signatures or pre-image of hashes. And how does a wallet reason about that without actually knowing the protocol? So that's where miniscript comes into play. Miniscript is a subset of Bitcoin script, and if you parse for the miniscript expression, that infers or implies satisfaction information about the script. So you know that you need a signature or of a certain pub key. So the wallet doesn't actually need to run the script. It just needs to parse the Bitcoin script to infer the type of satisfaction elements that is required. And so once it knows that, it can kind of build this model where, depending on the availability or non-availability of these satisfaction elements, it knows which states can be reached in the contract, which ones are safe, and when and how to sign, right? So this provides a wallet the ability to verify a smart contract without actually understanding the protocol, which is great. So yeah, that's the goal. This is something I'm working on. We want to do protocol agnostic miniscript contract verification. We want permissioned wallets, and we want to have a single wallet for all off-chain protocols. I want to plug a presentation at 5 o'clock by Andrew Polstra. He's going to talk about miniscript in Bitcoin. That's what this is all built on top of. Really, really cool. And my email is james@teachbitcoin.io. Love to talk to you about this if this is of interest to you later on. Thanks so much.
Yeah, so now we have Martin. You have slides.
Hi, my name is Martin Etzrod, and I'm working with the Akasha Foundation. Actually, this is a foundation founded by Michal, co-founder of Ethereum, and is in Zug. So William might know us. So I'm a natural scientist. My field is has been stem cell research. This is a very immature field. Biomedical research suffers a lot from reproducibility problems and a lack of collaboration. But it might apply also to other topics. So my claim is that what we don't need actually is more scientific journals. And there's an idea by a predecessor of Thomas Kuhn, who defined so-called Denkkollektive, thought collectives. This is a certain amount of community of people, usually small, that comes together and then is working on a collective idea. This is actually happening here. What we have with the advent of the internet and the web is that these collectives can basically associate or be created globally and borderless. The problem is that we didn't solve the problem of actually making this process very rapid and allowing the people to be attributed for their contributions. I realized that's a problem in at least my field, and with a couple of friends at the biosystems department, we did this experiment asking ourselves whether we could notarize data using the Ethereum blockchain and store this decentrally on IPFS. But actually the real solution or the real benefit here is this notarization. We can timestamp our data and our claims and prove that we have generated a data set or modifications of this at a certain time. What I realized is that there was a project, the Akasha project, that has been using the same technological background and trying to build a decentralized, permissionless, and censorship-resistant social network as an alternative, for instance, to Facebook or other centralized systems. And what I'm currently trying to do is to within the team of Akasha, try to exploit this and see whether we can build a communication platform that's an alternative to publications, and it's more like a microblogging form of sharing, either long but also short forms of information. So what we have now is already achieved through Ethereum at IPFS or other means of blockchain, permanent publication, attribution of contributions, and interoperability. What we are now lacking is actually ways of funding and maybe creating value with these knowledge bits that we can share borderless on this network.
All right, so now we have Ken Lang.
Hi, I'm Ken Lang, and I'm going to talk about what makes for an ideal long-term store of value. An ideal blockchain-based long-term store of value is very important because it can be used for smart contracts, collateral, staking, and as a general method that demonstrates commitment to good faith behavior from others across a globe-spanning network of participants. Ideally, such a long-term store of value should not be pegged to something like fiat that has a mandate to lose value over time through inflation rather. It needs to be a place for capital to be happy to rest without a high opportunity cost. And while the hopes are high for Bitcoin to serve this purpose, if scaling larger should lead to its volatility being sufficiently reduced, this remains unproven. But why wait and hope when all of the tools of monetary policy are able to create a much less volatile, ideal long-term store of value right now? And what if we can add more resilient, decentralized, blockchain-based institutions into the base layer of the protocol to solve issues like high-quality, transparent governance, identity, dispute resolution, and oracles? What if we can make an ideal long-term store of value that has many of the properties of Bitcoin that we like, but also has properties that make crypto more friendly and acceptable to the non-crypto world so we can all more rapidly expand the domain and usability of crypto for the larger world? If you find that much of the crypto industry dogma may be the source of what's holding the industry back from wider acceptance, that we in the crypto world may have too radically thrown the baby out with the bathwater, then I'd like to suggest a project to take a look at that may have ideas that capture the best of both worlds. It's called ENDAO, and it's short for the Endowment of Assets that help support the monetary policy, and it may be something worth a look at, either to get involved with yourself or because there are ideas there that might be useful for your own project. The only slide I have here today is my shirt, so you can see the unorthodox spelling, NDAU. And if you're interested in trying out something that may be a more of a best of both worlds approach to how to store value long term and its use cases, just come to endao.io and you can check out the white paper, and it's a token that's already out there running and available on exchanges if you're interested in that too. Thank you.
Okay, now we have Avishay. You have slides.
Hello, everyone. My name is Avishay Yanai from VMware Research. A big problem that blockchain designers encounter is how to preserve the anonymity of their users. So solutions like Zero Cash and Monero indeed provide content anonymity, which means that given a transaction, I could not tell who is the source. However, they do not provide network anonymity, which means that if I do traffic analysis in this room and observe some transactions for Bitcoin, for example, then I could leak some information about the senders. Another problem that was presented yesterday by Ari Jules is front running, by which a malicious user may behave adaptively depending on the inputs of other users. Recently, together with Itai Abraham and Ben Pincus, we constructed a system called Blinder, which allow anonymizing clients of a blockchain. So the system is maintained by a large set of nodes, of which fraction could be malicious and colluding. And it operates over rounds or epochs, where in each epoch, a lot of clients can send messages to the servers in a secret sharing manner. And in the end of an epoch, the servers reconstruct all messages, but in a shuffle manner, so nobody could link a message to its source. The system is built over state-of-the-art secure multi-party computation, and its special structure allows us to achieve far better performance than all previous solutions in comparable settings. For example, Blinder can support 1 million clients with tweet-sized messages in about 10 minutes, whereas previous state-of-the-art could do this with more than 10 hours. We'll soon publish the source code and the paper. In the meantime, I'll be happy to share more information with you privately. Thank you.
Yeah, so now we have Navroop. Yep.
All right. Hi, everyone. My name is Navroop Sahdev. I'm an economist by training. Been in the blockchain space for 4 years. I'm also a fellow at MIT Connection Science here at the Media Lab. And I've been listening to presentations since yesterday morning, and we had some excellent set of presentations on economics, particularly your panel, Sharon. And we have more coming. But what I really want to share with you, and since this is a field building summit, is what is next? What is it that hasn't been covered? So I want to leave you with 2 key ideas at the intersection of blockchain and economics and everything else that I think haven't been, we as a community haven't touched upon yet. And the first one of them is the impact of increasing connectedness on economic structures. What we lacked so far is what is happening as a result of newer technologies, emerging tech, to the economy as a whole. So this could be national economies, local economies, or the global economy. So we're talking about creating these new economies, but we're not really studying the impact on the economic transformation. So Joseph Schumpeter talks about creative destruction. So I think of economies that constantly reinvent themselves as part of that process, or vice versa. So maybe it's an open call to those of you who are interested to think about that. And the second idea that I want to leave you with is that of technological convergence. So it is a blockchain conference, but technologies don't work in isolation, right? So the question is, can blockchain be the infrastructure technology that can lead to technological convergence? And what do I mean by that? Well, there are tools like AI and machine learning and AR and VR. So really think about blockchain as the infrastructure at the bottom, but all these things that we can do with other technologies on top of it, and that I think is something that might lead us into a future that we don't quite recognize. So that conversation is still pending. So maybe in the next summit in March. One call for action, I'm co-editing a book on redefining the theory of the firm. Well, why do firms exist? What functions they perform? So we are looking for chapters, 3 or 4 chapters more, the rest are done. So please come talk to me, I'll send you the link. And for all these conversations, I launched Rethink Markets, not launched yet, so come talk to me. It's an economics think tank focused on emerging tech. Thank you very much.
All right, yeah, I think that's everyone. So thanks everyone for coming.